Terminating transport layer security at the ingress controller leaves internal cluster traffic unencrypted, violating strict compliance requirements. We need true end-to-end encryption, meaning the connection remains secure all the way to the application pod. Cert-Manager solves the certificate lifecycle automation, but integrating it for internal use requires specific configuration beyond standard ingress setup. We must define a mechanism for the application to trust the certificate issued by Cert-Manager and ensure the ingress controller forwards traffic securely. This process involves two distinct certificate stages: the public certificate for external trust and often an internal certificate authority for service mesh communication. Our focus is automating the public certificate issuance and forcing the ingress to use secure sockets layer when connecting to the backend service. This eliminates the plain text hop inside the cluster boundary, a critical security vulnerability. Begin by installing Cert-Manager using Helm. Execute the command helm install Cert-Manager, jetstack, Cert-Manager, namespace, Cert-Manager, create namespace, version v1.13.1, set install Cert-Manager webhook, true. This deploys the controller, the webhook, and the application programming interface resources necessary for certificate management. Verify the installation by checking the custom resource definitions. kubectl get custom resource definitions .certificates.certmanager.io. The controller pod must be running and healthy before proceeding to define issuers. If the webhook fails to start, check the Kubernetes version compatibility, as Cert-Manager relies heavily on mutating and validating webhooks for resource validation. Ensure your cluster has sufficient resource quotas in the Cert-Manager namespace. The ClusterIssuer resource defines how certificates are obtained, applying cluster-wide. We use the Automated Certificate Management Environment Protocol via Let's Encrypt. Define the server endpoint as https://acme-v02.api.let'sencrypt.org/directory for production certificates. Crucially, specify a valid email address for registration and renewal notifications. The solver block dictates how domain ownership is proven. For initial setup, we use the HTTP01 solver, which requires an ingress configuration. The ClusterIssuer must reference a secret where the account key will be stored. This key is used by Cert-Manager to communicate securely with the Automated Certificate Management Environment server. Remember, using a ClusterIssuer means any namespace can request a certificate using this definition. For the HTTP01 challenge to succeed, the ingress controller must be correctly configured to route the validation request. We assume the Nginx Ingress controller is deployed. Cert-Manager automatically creates a temporary ingress resource specifically for the challenge path, typically starting with .wellknown/acme-challenge. The Nginx controller must be listening on port 80 to receive this request from the Let's Encrypt validation server. Ensure your load balancer or firewall allows traffic on port 80 to reach the ingress controller service. If you are using a cloud provider load balancer, verify that health checks are correctly configured and not interfering with the challenge process. The ingress controller is the gateway for domain verification. The certificate resource is the core object that triggers the issuance process. Define the secret name where the resulting transport layer security key pair will be stored, for example, myapplication-TLS. Specify the common name and the list of subject alternative names, which must match the domain names exposed by your ingress. Reference the ClusterIssuer defined previously using the issuer ref field. Set the renew before field to specify how many days prior to expire Cert-Manager should attempt renewal, typically 30 days. Once applied, Cert-Manager creates a certificate request resource, initiating the communication with the Automated Certificate Management Environment server. The resulting secret will contain the tls.crt and tls.key files.
When the certificate request is created, Cert-Manager initiates the HTTP01 challenge. It instructs the Automated Certificate Management Environment server that it is ready to prove domain ownership. Cert-Manager then creates a temporary service and a specialized pot, the Acme solver, which serves the required token at the specific challenge path. Concurrently, it creates a temporary ingress resource that routes the challenge path to this Acme solver service. The Let's Encrypt server then sends a hypertext transfer protocol request to your domain on port 80, hitting the temporary ingress, which forwards it to the solver pod. If the token matches, the challenge is successful and the certificate is issued. This entire process must complete within a few minutes, or the challenge times out. To achieve true end-to-end transport layer security, the ingress resource must be configured to use secure sockets layer when communicating with the backend service. First, ensure your application service is configured to listen on Hypertext Transfer Protocol Secure, using the certificate stored in the secret generated by Cert-Manager. Next, Annotate your ingress resource with nginx.ingress.kubernetes.io/backend protocol equals HTTPS. This forces the Nginx Ingress controller to establish a transport layer security connection to the upstream service endpoint. If the backend service uses a self-signed certificate or a certificate issued by an internal certificate authority, you may need additional annotations to skip certificate verification by the Ingress controller, such as nginx.ingress.kubernetes.io/SSL verify equals off. However, for maximum security, the backend should trust the public certificate or a dedicated internal certificate authority. The most common failure points are challenge timeouts and incorrect domain validation. Always start debugging by examining the certificate request resource. kubectl describes certificate request my application TLS. Look specifically at the event section for detailed error messages from the automated certificate management environment server, such as rate limiting or connection refused. If the challenge fails, verify that the temporary ingress resource created by Cert-Manager is correctly routing traffic and that the Acme solver pod is running. Use curl from an external network to test connectivity to the .wellknown/Acme challenge path on port 80. If the connection is refused, the firewall or load balancer configuration is incorrect. If the connection times out, the ingress controller is not receiving the traffic. For wildcard certificates, the HTTP 01 challenge is insufficient. You must use the DNS 01 solver. This method proves domain ownership by creating a specific text record in your domain's domain name system zone. Configuring DNS 01 requires providing Cert-Manager with credentials to interact with your domain name system provider's application programming interface, such as Amazon Web Services Route 53 or Cloudflare. Define the specific access key and secret key within a Kubernetes secret, and reference this secret within the ClusterIssuers DNS 01 solver configuration block. This allows Cert-Manager to programmatically create and delete the required text record for validation. Once validated, the wildcard certificate is issued, covering all subdomains under the specified domain.